Good morning, my dear students. So again, here in this ppt I'm going to derive one equation that is a forced damped vibration with a constant harmonic excitation. Okay, I told you what you mean by harmonic and what you mean by excitation in the previous class. Okay, harmonic is nothing but what it is a force of in the form of sine omega t. Okay, that is called as an harmonic excitation force. Okay, so here this derivation is also very important for the point of examination, and they may ask you around 10 to 12 mark question. Okay, so forced vibration. Okay, so let me consider a spring mass damper system. Let me understand this diagram first. Okay, so consider a spring mass damper system. So here I shown the figure a b c. Okay, figure a b c, consider a spring mass damper system. Okay, so all are spring mass damper system only. Okay, so figure a shows the original position, figure b shows the displaced position, and the third diagram is shows the what are the forces acting on that. Okay, so before solving this you have to remember the D'Alembert principle. Okay, so D'Alembert principle states what the summation of inertia forces plus external force is equal to 0. Okay, so here this is a spring mass damper system, this is a k, that is a spring that is a k, and this is a damper c, and this is a mass. Okay, so here just you apply the external force, that is the external harmonic force, f naught is equal to sine omega t. Okay, so this is about the initial diagram. So just if you displace at a distance of y, that is that's a distance of x, that is you are going to applying the external force here. Okay, f naught sine omega t means it will pull downward direction. So that diagram, that pulling downward direction with respect to time t, so that I shown in the figure number b. That is, here I am just to observe here the mass is here in equilibrium position, but whereas here mass is some distance. Okay, from equilibrium position to this distance. Okay, that distance is pulling with a harmonic force equation, that is f naught sin omega t. Okay, so this is about the difference between figure a and figure b. Okay, so once if you pull down, there is a just while figure c, if you want to derive this equation you have to consider the free body diagram of this. Okay, what all are the forces acting on this? So one is the top, that is a spring force that is acting, this is the spring force acting on the top, and the damper force, that is c of x dot, is acting on the top, and the motion will be always opposite to the what inertia forces. Okay, motion is in downward direction, this is an external force, that is a harmonic force f naught sin omega t, and this is the motion, that is the inertia force, is acting upward direction, m x double dot. Okay, so this is about the free body diagram. Okay, I hope you understand all these three diagram. Okay, so I mentioned here also f naught is equal to what external excitation force, and f naught sin omega t is harmonic external excitation force. Okay, so same I told here, the consider spring mass damper system, same subject to a harmonic force f naught. If the force is f naught act on the particular system, the mass m is displaced from a static equilibrium position by a distance of x in a downward direction. Okay, the external force acting on the system at any instant of time are shown in the figure b. Okay, I shown here just to at a distance of x it is displaced and pulling down direction. Okay, so here these are the forces acting on that particular element. Okay, 1 2 3 forces acting on that, along with that inertia forces. Okay, so next the how many forces are acting on that? The forces acting on the systems are the spring force, that is called as a restoring force, that is k of x. Okay, that is acting in upward direction. So damping force c of x dot, that is also acting in the upward direction. External force f naught sin omega t acting in the downward direction, and the inertia force m of x double dot is acting on the upward direction. Okay, upward direction you are going to take the positive, and downward direction you are going to consider the negative symbol. Okay, so according to the D'Alembert principle, the summation of external forces plus inertia force is equal to 0. So external force is what k of x plus c of x dot plus mx double dot minus f naught sin omega t is equal to 0. Okay, so this is a very big derivation, just to remember. Okay, so be careful. Okay, so just to re-simplify this equation, mx double dot plus cx dot plus kx is equal to f naught sin omega t equation. Okay, so you are going to get the equation number 1. Okay, but here the linear equation, second order differential equation, and non-homogeneous. Okay, so to solve this we are going to get what you are going to get what the complementary function, and that is a particular integral. Okay, x of c and plus x of p. Okay, so this is also, if you want to solve this, okay, you are going to get the linear equation, that is complementary function and the particular integral function. Okay, so here this is also very important. Okay, so linear to solve this, this complete solution is given by what x is equal to x of c plus x of p. Okay, so okay, x of c plus x of p. Okay, complementary function is denoted by xc, and particular integral is denoted by xp. Okay, complete solution is x is equal to x of c plus x of p. Okay, complement, first we have to derive this xc and xp, next later xp. Okay, complementary function is equal to what? X of c is equal to what? Xc is equal is obtained by considering the no forces acting on the term that is in equation number 1. Okay, there is no external force acting on this, that equation you are going to consider. Okay, first here, so force is here f naught sin omega t. Okay, so just to neglect that, so m of x double dot plus ex plus kx is equal to 0. So you are going to get this. Above equation is same as general equation for the damped free forced vibration. Okay, so this is similar to what this is general normal equation. Okay, so this is similar to forced vibration equation. M of mx double dot plus ex dot plus kx is equal to 0. Okay, considering the underdamped vibration, okay, consider the this system is an underdamped system. Okay, that is a complementary function is equal to this underdamped system equation is what? The maximum amplitude e minus zeta omega n t sin of omega dt plus phi. Okay, so this is an underdamped system equation. Okay, where x1 and phi 1 is what? Constant to be determined. We have to derive the x1 and phi 1 equation. Okay, so but we know that omega d in model 4th, omega d is equal to what? Square root of 1 minus zeta square omega n. Okay, so just omega d you substitute in this equation, you are going to get this, that is a complementary function x1 is e minus zeta, that is e to the power of minus zeta omega n t sin of square root of 1 minus zeta square omega n t plus phi 1. Okay, so if you substitute this equation, you are going to get this equation. So in place of omega t, just to substitute this. Okay, that give equation number 2. Okay, so if once you calculated this complementary function, go for calculate the particular integral. Okay, so if you want to calculate the particular that is particular integral, that is it is also denoted by pi. Okay, so in pi, capital pi, and in terms that is also xp, x suffix p. Okay, but we know that the particular integral mx double dot plus cx dot plus kx is equal to f naught sin omega t. So already we derived this. Okay, so it is what it is in the if you look at the if you take the m3, while when we are going to study the m3 subject, that is in 3rd semester, we require that model. Okay, so this is similar to what the m, this is double dot nothing but double derivative, that is d square x divided by dt square. Okay, plus c into this x dot nothing but what? Dx by dt. Okay, plus kx is equal to this is external force is equal to what? R of x function. Okay, so this is while studying in m3 subject, you are going to solve same like this only. Okay, f naught sin omega t is equal to what? R of x function. Okay, so but R of x function is equal to what? Sin omega t. Okay, so here the xp is equal to the x of sin omega t minus phi. Okay, so this is similar to that equation that is in model, that is the when you are studied the m3 subject, no, that you take that knowledge. Okay, so xp is equal to capital X of sin omega t minus phi, where phi is nothing but what? The phase angle. Okay, so here you are going that phase angle you substitute. So here that is phase angle, x is nothing but the maximum amplitude sin of omega t minus phi. Okay, give equation number 3. Okay, so xp is equal to nothing but particular integral. Okay, where x is equal to amplitude of the steady state vibration. Okay, so here I shown in the diagram amplitude of steady state, just it is a simple harmonic motion. So the distance, the maximum amplitude to the mean equilibrium position, that x, that is you need to calculate here. Okay, that x is what? This. Okay, here the angle by which the vector large force that is a lags force the vibration. Okay, so here the lagging the vector and okay phase angle and the phase difference, and omega is equal to what? Circular frequency. Okay, look at the diagram here. Okay, so this is the take the down axis, that is the reference axis. Okay, so this is what the displacement axis. Okay, that is the displacement vector, and this is the angle, phase angle, and this is circular angle, that is a circular force, that is circular vector, that is circular angle. Okay, so here we have the xp particular integral is equal to what? Capital X of sin omega t minus phi. Okay, from this to this displacement vector, that is what angle is omega t minus phi. Okay, so this is what from reference axis to displacement vector, angle is called as omega t minus theta. Okay, so but the here the omega t is there, f naught external force harmonic equation f omega t. Okay, that is from the reference axis to the force vector. Okay, the force which is acting, the inclination angle is called as omega t. If you know this omega t and omega t minus phi, we know that the angle between force vector and the displacement vector is what? The phi. Okay, so this is about the vector diagram. Okay, now xp is equal to what? X of sin omega t minus phi. Differentiate this with respect to t, x of p is equal to x sin differentiation of cos omega t minus phi into this omega is there. Give question number 4. Okay, so again differentiate with respect to again x double dot is equal to what? The cos is minus sin. Okay, so minus omega square x sin of omega t minus phi. Okay, so give equation number 4 and 5 once if you differentiate this. Okay, so 4 and 5 you got. Okay, so put equation number 4 and 5 in equation number 1. So if you substitute all those values in equation number 1, you are going to get what? This, okay, minus m omega square x sin of omega t minus phi plus c omega cos of omega t minus phi plus k x sin of omega t minus phi is equal to external harmonic force f naught sin omega t. Okay, so here the common is what? Sin omega t minus phi and sin omega t minus phi is the both the side is common, just to take the common. Okay, so if you take the common, so inside is what? The if you take the common here, so here what? The k minus m omega square is as it is, so into this is not a into, this is a x. Okay, x of sin, x is nothing but what? Maximum amplitude. Okay, so sin of omega t minus phi plus c here again plus c omega x cos of omega t minus phi is equal to 0. This is not 0, f not sin omega t. Okay, so here both the side sin omega t minus phi is there, take common, you are going to get this equation. Okay, again k minus m omega square, this is what? The sin a minus b formula. Okay, so this is cos a minus b formula. Okay, just to simplify this, k minus m omega square as it is, x as it is, this is not a into, I am telling you repeatedly, this is a maximum amplitude. Okay, so sin of sin a cos b minus cos a sin b formula that you applied, plus again c omega x, here cos a minus b formula is sin a sin b plus cos a cos b formula. Okay, that you apply here formula f naught sin omega t again. Okay, so here again both the side the next step is again the sin omega t is common is there, k minus m omega square x of cos omega phi plus c omega x sin phi, so sin omega t if you take the common. Okay, again in the right hand side, that is next is cos omega t is take common side. Okay, so here take the sin omega t and cos omega t common. Okay, so you are going to get this equation, and the external, that is RHS is f naught sin omega t. Okay, so compare the quotient of the both the LHS and RHS. Okay, so here you compare the equation, both f naught sin omega t is there, sin omega t, so f naught value is this. Okay, cos omega t, just to consider 0 plus 0 into cos omega t. Okay, f naught sin omega t plus 0 into cos omega t, just to compare the both the coefficient on both the side. Okay, so if you compare this, you are going to get f naught is equal to this k minus m omega square x cos phi plus c omega x sin phi is equal to f naught. Give equation number 6. Again the 0 is equal to the remaining, that is c omega x cos phi minus k minus m omega square x into sin phi is equal to 0. Give equation number 7. Okay, so from equation number 7 here from the equation number 7, just to again resimplify this, c omega x cos phi is equal to k minus m omega square x into sin phi, just to transfer to RHS. Okay, so x is going to get cancelled, you are going to get what? Sin phi by cos phi is equal to c omega by k minus m omega square. Okay, sin by cos is nothing but what? Tan phi. Okay, so this is equal to c omega whole divided by k minus m omega square is equal to that is what? This is whole divided by k minus m omega square. So give question number 8. Okay, so here the we are going to get the phase angle phi is equal to what? Tan inverse of c omega whole divided by k minus m omega square, equation number 9. So this equation number 9 is called as a phase angle. Okay, or phase difference. Okay, from equation number 8, determine the value of sin and cos phi. Okay, so we know, consider one triangle. Okay, so here sin alpha is equal to what? Opposite by hypotenuse. Construct opposite by hypotenuse. Okay, so construct one triangle. So here the given values already sin values, and we already calculated sin values and cos values. Okay, sin values and cos values we are going to already calculated. So here the sin value is the opposite value is what? Here sin opposite by hypotenuse, so opposite is c omega, so k minus m square. So what is the use Pythagoras theorem here. Okay, so square root of k minus m omega square plus c omega square. Okay, so opposite is c omega, this is the opposite sign, hypotenuse is nothing but this equation. Okay, right here sin opposite by hypotenuse. Okay, similarly cos phi is equal to adjacent by hypotenuse, so adjacent is k minus omega square whole divided by hypotenuse is this value. Okay, put sin alpha and cos alpha in equation number 6. Okay, so if you substitute equation number 6, so you are going to get like this. Okay, k minus m omega square x cos phi plus c omega x sin phi is equal to 0. Okay, if you take the here the x is common, x is equal to inside k minus m omega square cos phi plus c omega sin phi is equal to 0. Okay, so x is equal to what? So f naught whole divided by, if you transfer this that side, f naught is equal to k minus m whole square, that is m square cos phi plus c omega sin phi. Okay, so again x is equal to what? So divide and multiply by this square root of k minus m whole square plus c omega whole square. If you divide this, okay, So f naught whole divided by k m minus m square is equal to, if you divide this, okay, otherwise you substitute cos alpha sin alpha value here, okay. So cos alpha sin alpha value is what, I not divide, so you just to substitute sin phi and cos phi values here, okay. If you substitute, you are going to get this. Again take the here the in the denominator, this is a common. If you take this common, x is equal to f naught whole divided by k minus m omega square whole square plus c omega whole square. So divided by the square root of k minus m omega square plus c omega square, okay. So from this, so x is equal to what, f naught by, so this is a one going to get cancelled, so remaining is square root of k minus m omega square whole square plus c omega square. So give question number 10, okay. Again divide numerator and denominator by k. So x is equal to f naught by k, so whole divided by square root of 1 minus k, k is going to get cancelled, 1 minus m omega square divided by k plus c omega square by k, okay. So these two equation 10 and 11 are the what, the maximum amplitude, okay. So again if you want to resimplify this equation, again if you want to resimplify this equation, so but we know that what, the m omega square k, so okay, m omega square by k, we know that omega k can, okay, m omega square by k is equal to what, omega square k by m, we can write like this. Again omega square by omega n square, so k by n is nothing but what, natural frequency I mentioned here, square root of k by n, so omega by omega n whole square, okay. So okay, this is about the value of m omega square by k, okay. But c omega by k is equal to what, and we know that zeta is equal to c by cc, c is equal to cc by zeta, cc is equal to what, 2m omega n, c is equal to 2m omega n, okay. So replace wherever c is there, just to substitute here, you are going to get 2m omega n zeta into omega by k, okay. So again this, if you simplify this, you are going to get 2m 2 omega n zeta omega, okay. So divided by k by m, okay. So here omega n are going to get cancelled, okay. So k by n is nothing but omega n square, okay. Omega n square are going to get cancelled. So finally you are going to get c by omega by k is equal to zeta omega by omega n, okay. So substitute these two values in the previous equation, you are going to get the final x is equal to f naught by k divided by square root of 1 minus omega by omega n whole square to the whole square plus 2 zeta omega by omega n whole square, okay. Give question number 12. So where x is the maximum amplitude of steady state vibration, okay. This equation is very very important for solving the problem. You have to remember by heart this equation, okay. So again from equation number 9, we know that phi is equal to tan inverse of c omega by k minus m omega square, okay. So again okay, so phi is equal to what, tan inverse of c omega by k. So if you just you divide by k, 1 minus m omega square by k, you are going to get, okay. So put this two equation m omega square k and c omega by k values, we are going to get the phi is equal to tan inverse of 2 zeta omega by omega n whole divided by 1 minus omega n whole square, okay. So give question number 13, okay. So this 13 equation is called as phase angle or the phase difference equation of steady state maximum amplitude, okay. So now we know that the xp is equal to x of sin omega t minus phi, okay. Xp is equal to what, the particular integral function f naught by k sin of omega t minus phi whole divided by square root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square, okay. So from equation number we know that the complete solution is given by x is equal to xc plus xp, okay. So substitute xc value from equation number 2 and xp is equal to from equation number 13, you are going to get the general solution for this equation. X is equal to x1 of e minus zeta omega n t into sin of square root of 1 minus zeta square into omega n into t plus phi plus, so f naught sin omega t minus phi whole divided by square root of 1 minus omega by omega n whole square whole to the whole square plus 2 zeta omega by omega n square, okay. So this is about the complete solution for this solution, this equation, okay. So this derivation is very very important, okay. This derivation is very very important for the point of examination. You have to remember the step by step procedure I explained. Please refer the notes, and in the notes we have to practice number of times, okay. They may ask you on direct question, okay. So this derivation is called as what, a forced vibration within constant harmonic excitation force, okay. So I hope you understand this. Thank you.